Yeah, hi. Myself Deepak Sharma, and today we'll discuss about some another important questions from the exercise 1.2 real numbers, and this is extremely sorry. This is most important question for your upcoming exams. Okay, your exam will be happen 10th of March. You know about it, so I'm proving this question. So I'm writing it proof. Basically, in this type of question, what we have to do here? Prove that root 5 is an irrational number. So how we can prove it? It's a irrational number. You know that the definition of rational number and the irrational number also. If you are talking about the rational number, so we can say that if any number which can be expressed in the form of P over Q, then it would be called the rational number. And some extra information I'm adding here. Q is not equals to 0, P and Q are co-prime numbers, like that. Okay. And the second definition, which is irrational number, it means that we can say that if any number which is not a rational number, so it would be called the irrational number. It means that if we are proving here root 5 is not a rational number, then we can easily say that it's root 5 is an irrational number. So I'm just doing it. I'm just considering it this thing. Let us assume, I'm writing it, let us assume root 5 is a rational number. 5 is a rational number. Okay. So if I'm saying it root 5 is a rational number, then you know that. You know about it. Root 5 is a rational number. It means that we can express in the form of P over Q. Okay. So I'm writing it down here. That is root 5 is in the P over Q form. And you know that PQ is a prime number. So since we know that here, we know that here P and Q are integers or co-prime numbers. Are co-prime numbers. So here we have to note down one thing. What is co-prime number? Co-prime number, it means that we can say that if two numbers have only one common factor means one digit, one common factor, then we can say that PQ have co-prime 1, or we can say that PQ is a co-prime numbers. Okay, so I'm directly writing it here. Um, Actually, it's a root 5, not P. I written down wrong here. So I'm just directly writing it 5. Okay. So we can write it root 5 Q is equals to P. Okay. And after that, what we have to do here? We have to just writing it down, the squaring both side. If I'm writing the squaring both side, this is the process which we are doing. Squaring both sides. If I'm squaring both sides, then it would be, we can write it root 5 whole to the power of 2 and then p square. Okay, and then what we have to do, root 5 is square, it means that it's a 5, so I'm directly writing it 5, and it would be q square. Okay, and then it would be p square. So we can write it down here. Q square is equals to p square over 5. Did you get it this thing? I hope you are getting it. So I'm writing it down here. One theorem you know about it. If P is a prime number, this P I'm talking about. If P is a prime number and P divides P square and P divides P square, it means that I'm talking about the other sense. Prime number, if you are taking prime number, any prime number, okay? If I'm talking about 5 is a prime number because prime number have uh, it have only it is divisible by itself or 1. So if I'm talking about 5 is divisible by 1, then 25 is also divisible by 1. Okay, I'm talking in the another sense. So I'm talking that if 3 is divided by 3, so 9 would be divided by also 3. And it is the uh, if and only if condition. Okay, means sufficient condition and converse condition are true. So I'm writing it down. If p square is divided by 5, so we can write it down. So p is also divided by p is I'm writing it down here. P square is divisible by p square is I'm writing it here. If p square is divisible by 5, therefore we can directly write it. P is also divisible by p is also divisible by 5. Okay, so we can write it directly. We can write it p is divisible by 5 like that. P divides 5. Okay, so you know what you are understanding. If why p divides 5 5 divides by p here, you know, if any number divides other number, it means that the exact number is factor of p or the others number. Like if I'm talking about 4, so 4 is divisible by 2, it means that 2 is a factor of 4. So I'm directly writing it here. 5 is factor of 5 is factor of p. P. So equation number 1, just consider it. Now I'm talking about the another thing. We have to take another case, okay? So I'm writing it down here in the short space. I'm just considering it here. I'm saying P is equals to 5R. Let P is equals to 5R. Here I'm taking another number, okay? Another number which is R. It's you can take it like it's integers or co-prime numbers, okay? So now what we have to do again here, we knew about it. Uh, this condition we knew about it. A 5q square is equals to p square. Okay, so I'm putting it down here. Uh, since we know that 5q square is equals to p square, therefore I'm directly writing it 5q square and p is equals to 5r. So I'm writing it 5r square. Okay, and then what we have to do here, it would be 5q square is equals to 25r square. Okay, so you knew about it, this one would be cancelled, then we can write it q square is equals to 5r square, and then we can directly write it here, then write it down here. R square would be q square over 5. Now here it's the same condition like this. Therefore, if q square is divisible by q square is divisible by 5, therefore we can easily write it down. Q is also divisible by q is also divisible by what? Divisible by 5. So we are coming on the next slide, and then or you can write it down, pause the video and write it down. Okay, now we are coming on the next slide. So uh, I'm just doing it. Yeah. So what we have to write it down here in the next in the previous slide we written down q is also divisible by 5. It means that 5 is a factor of q. So I'm writing it down here. That is directly writing it q is divisible by 5. Therefore we can directly write it 5 is a factor of q. Since we assume that, since we assume as P and Q are co-primes, are co-primes. Co-primes means what? The common factor is 1, should be 1. Therefore, then we can write it down. Then P and Q must have must have factor 1, factor 1. But but here 5 is common factor. 5 is common factor for P and Q. P and Q. Therefore, we can directly write it down. Our assumption is wrong. Our assumption is wrong. Then, or therefore, hence, we can directly write it hence, root 5 is an irrational number. Is an irrational number. Okay. I hope you understood well and exactly. Okay. So we are going on the next question on the next slide, then we'll discuss about it. So I'm coming it here. Okay. Uh, Wait a second. Mm, yeah. Okay. Um, yeah. So we have to prove this one. Prove that the following are irrational. It's also most important. That's why I'm discussing here. So I'm writing it down. Solution. So how we can prove it? It's a very easy, very easy. So I'm proving it down here. Again, we have to consider 1 over root 2 is a rational number. So I'm writing it down. Let us assume, let us assume 1 over root 2 is a rational number. Okay, so it's a easy man. So rational number. Therefore, we can write it down. Therefore, 1 over root 2 is equals to p over q. Okay, so how we can write it down? So we can write it down here. Here's just do the cross multiplication. If you are doing the cross multiplication, then it would be q over root 2 is equals to p. And then what we have to write down, q over p is equals to root 2. You know that this number is rational number and this number is irrational number. So I'm directly writing it down here. This is rational number, rational number in all condition, okay? Here in all condition it's rational number and this one is irrational number. Irrational number, okay? So I'm writing it down here. Therefore, we can directly write it down. Rational number never be equal to irrational number. Okay? Irrational number. Hence, 1 over root 2 would be root 2 is an irrational number. Irrational number. I hope you understood exactly. Okay. But in the previous question, we can't express like this. Okay. That's why I took a big process. Okay. And I hope you understood all the process, all the concept. Okay, now we are coming for the next important questions. So this question is most important for your upcoming exam. Okay, just mark it as a most important. Okay, so now I'm doing it. First of all, I'm reading it. What is it? Consider the numbers 4 to the power of n, where n is a natural number. Check whether there is any value of n for which 4 to the power of n ends with the digit 0. Okay. Like, if I'm talking about if 4 to the power of n is a natural number. N is a natural number. You know about it. Natural number, it means that it's starting from 1 and it will be go through infinite till the infinite. So we can directly write it down. It's a till the infinite. Okay. So 4 to the power of, if you are putting it 4 to the power of n sense. So it means that 4 to the power of m1, 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, 4 to the power of 6, 5, like that. It is going like that. Am I right? So now, uh, directly we have two methods to prove this one. This is the first method, like which I'm doing right now, and the second method is most important, which I'm solving it. This one we have to just memorize it. Okay, now I'm solving it here. So I'm writing it down here. If I'm taking it, I am taking it, taking same numbers which ends, same numbers which ends with 0. Okay, which ends with 0. So if I'm taking it, those numbers which ends with 0. So I'm directly writing it down. It's a 10, right? So it would be 2 times 5. Okay. If I'm talking about 20, so 20 it means that 2 times 4. Is it correct? If I'm talking about 30, so it would be 2 times 3 times 5. Okay. I think it's wrong. We can write it as a 5. Okay. And now if I'm talking about the 4, so it would be 2 times 2, and then 5. Okay. You are understanding better. I hope you are understanding. So if I'm talking about 100, then it would be 20 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is um 8 times 2, just write it down and then 5. Okay, just wait a second. 2 times 2 is 4, 4 times 5 is 20, 20 times 4 is um here we have to just write it down like that. 5 times 5. So 25 times 4 is equals to 100. It means that if any number which ends with 0, it means that they have factor 2 and 5, factor 2 and 5, factor 2 and 5, factor 2 and 5. It means that directly I'm writing it down 4 to the power of n. We can write it down 2 times 2 to the power of n. Okay, right? So what we have to do now, we notice that we notice that in those example, in those example, we got a we got 2 and 5 as a factors, right? For instance, the number, so ends the number with 0, ends the number with 0. Okay, so then we can write in, but 4 to the power of n have 2 times 2 to the power of n, it means that 5 don't have, uh, but doesn't have factor 5, factor 5. Hence, directly we can write it down 4 to the power of n never never ends with 0. Now it's end, okay, and I will upload shortly. So now I'm saying it, if you are liking this video, if you're enjoying, then please like my video, subscribe my channel, and support me. Actually, I need your support. Okay. Thanks a lot. Thanks for watching. Thank you so much.